Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. In this video, we're going to proceed with second hour tutorial for benzene and its derivatives. For non-face-to-face questions, we are going to outline the mechanism for these reactions. So we have benzene to react with chlorine gas in the presence of FeCl3 to give chlorobenzene and HCl as the side product. So we could see that these reactions involved the reactions on the benzene itself, where we are going to substitute the H with the Cl. So we're going to do the 3 steps mechanisms. So the first steps involve the formations of electrophile. So our electrophile will have a reactions between chlorine gas and FeCl3. So we're gonna write the Cl2 together with its lone pair react with FeCl3. So by having these reactions, we're gonna form an electrophile of positive ions. So we're gonna first donate one of the lone pair of the Cl, and then we'll form a complex ion of Cl FeCl3. If we look closer at the Cl in the middle, we're going to have a formal charge of positive 1. So we need to indicate this is positive 1 and negative 1. We cannot break the bonds between this Cl and Cl bond yet because it is very hard to form Cl plus charge. So we need to bring this complex ion to the second step. As for the second step, we're going to form Adrenium ions. So Adrenium ion is basically benzene with positive charge. So we are going to involve the reactions with the benzene this time. So we're going to start with this benzene. So benzene will act as a nucleophile that will always attack. They are going to attack the complex ion we have formed earlier. So this is going to be positive and this one is negative charge. So by reacting this benzene, we're going to break one of the double bond to the Cl and then break the bonds between the Cl and Cl. Then we're going to have an intermediate species of benzene. Keep the other double bond as it is, but when it comes to the double bond that have been broken, we are going to have one of the bond is H, another bond is Cl. Don't forget that the other carbon is now an electron deficient species, then we need to write the positive charge. Since this benzene is completely conjugated and they can form resonance structure, then we have to start our structure here with a bracket, and then by moving the double bond to the other side, then we are going to get this resonance formed. So we're going to have 3 of them because we have 3 double bond we can move around. So once you move this double bond here, you're going to get a double bond at a new place. And then don't forget that this carbon has become carbocation ion, and together with this H and also Cl. And then we can form another resonance structure of this Adrenium ion by moving this double bond to here. Then we're going to get a benzene. Now double bond is in here and also here. H and Cl. Now your positive charge is in here, the carbocation ion. Don't forget to close your structure with the square bracket. Alright, so we'll proceed to the third step. The third step is where we are going to retain the carbon-carbon double bond inside the benzene by losing hydrogen plus. So we are going to take one of the resonance structure here. Let's say we'll take this structure, and then we're going to further react them with the nucleophile being formed in the step 2. Oh, I forgot to write this nucleophile. So we're going to have FeCl4 negative as a nucleophile. So you need to write the structure like this since we are going to show the bond breaking between them. Okay, so we have negative charge in here. So in order for you to take out the hydrogen at one of the bond on the benzene, we are going to first break the bond between this Fe and Cl, because Fe got so much electron on it. So by transferring all the electrons on this bonding to the Cl, they're going to become negative charge. Then you can simply take this negative charge to the H and then break the bond between them and give it back to this single bond so that they can form multiple bond. And lastly, our final product going to be benzene that has now got all its multiple bonds again, and then we have Cl attached to this benzene. Then don't forget the side product, which is the HCl, and look, you are going to regenerate the FeCl3. Let's do the face-to-face questions. Benzene will undergo electrophilic aromatic substitutions with nitric acid, HNO3, in the presence of H2SO4. Show the mechanism for these reactions. So the questions want you to show the mechanism for these reactions, but before you start the mechanism, you need to first write the reactions equations. So you're going to have benzene as your starting materials, and then you're going to react them with nitric acid in the presence of H2SO4, and don't forget the conditions in here where we need 50 to 55 degrees Celsius, and you aim to substitute one of the hydrogens with nitro group. So we're going to have nitrobenzene for the products together with water as the side products. So we'll proceed with the 3 steps mechanism. So step 1 gonna always involve the formations of electrophile. So our electrophile now can be formed from the reactions between nitric acid. So we need to know how to write this nitric acid correctly in order for you to show the bond forming and bond breaking. For nitric acid, since we aim to substitute the H with nitro group, so let's set aside the nitro group here. So we have NO2, and attached to it is the O with 2 lone pairs together with the hydrogens. Then we're going to react them with H2SO4. So we have done this earlier in chapter 5. So we're going to write it as O, O, SO3. H indicates that this is sulfuric acid. The lone pair on oxygen at this nitric acid will take this hydrogen in and then break the bond between these H and O. And then we're going to get an intermediate of NO2. Now your oxygen has donated one of the lone pair, and they're going to have bonding with these 2 hydrogen, left with only 1 lone pair. It means that your oxygen now has become a proton. And then we're going to have these OSO3 H species. This is our nucleophile that we are going to bring it back in the final steps. Okay, so look carefully at your compound. So we have oxygen with positive charge. So we aim to take in the NO2, not the oxygens. So look, if we can already break the bond between the O and N. Yep, because we use the logic that we are going to release water, and water is stable enough to move on its own. So we're going to further break the bond in here. So since N is located at group 15, while oxygen at group 16, then all the electrons will be given to this oxygen because they are more electronegative. Then we're going to have an intermediate species of NO2 plus and H2O. So now this NO2 gonna become our electrophile, and we need to bring this at the second steps. As for the second steps, we are going to involve the reactions with the benzene. So we have the benzene to start with, and then we have NO2 plus as our electrophile. So we can simply break the bond in here and give it to nitrogens. We can break the bond in here and give it to the nitrogens. And by doing this, nitrogen will be inserted to this benzene. Don't forget that one of the carbon has now become a carbocation. So we have H in here and also NO2. Means this hydrogen, this carbon going to be positive. And then we're going to form resonance structure. By moving this double bond to here, we're going to get a resonance structure of this adrenium ion. 1, 2. Don't forget to write this H and NO2 together with the positive charge in here. We move it around. Then we're going to get another resonance structure of adrenium ion. So we have it here, H, NO2, and the carbocation. Don't forget to put the square brackets to show if they are resonance. And then for the last step, step 3, we'll lose the hydrogens from this adrenium ion. So take one of the resonance. So we have this H, NO2. This is the positive charge. Then we're going to react them with the nucleophile we have formed in the first steps. So we have O negative, SO3H. So we want to regenerate the H2SO4. So one of the lone pair here will take this hydrogen and give the double bond back to this carbon. So we're going to get our final products of nitrobenzene, and we have regenerated the H2SO4. Okay, that's it for nitrations reactions. Then for question 2, we're given another reactions and we need to do the mechanisms again. So the mechanism always involve the 3 steps for the electrophilic aromatic substitutions. But this time around, you have different reactants from previous questions. You now have this haloalkane, and by having this haloalkane as your reactant, we aim to take only the alkyl group that attach to this Cl. So it means we're going to break the bond between the C and Cl. So since we know that this C and Cl is a polar bond, then we are going to have a heterolytic cleavage that will somehow give positive and negative charge. We need to first check the classes of carbon that has in this structure. So for this first carbon, we have primary carbon, secondary carbon, and primary carbon. So by doing this, we get to know what kind of major product we are going to form. There will be a mixture of product, primary and secondary, but then we are going to do the major products. So we have 1, 2, 3, 4, 5, 6 as our benzene. And then look carefully. The most stable carbocation formed will be the secondary carbocation. Means we are going to add the carbons at carbon number 2, and look, we have CH3 and CH3. Means you're going to get this kind of alkyl group together with the HCl as the side product. So the first steps gonna be the formations of electrophile. So we have these CH3, CHCl, and CH3. Show all the lone pairs on the Cl, and then we are going to further react this AlCl3. So this AlCl3 gonna be attacked by this lone pair of Cl, and then we're gonna form these complex ions of CH3, CH3. Just like in previous questions, we're gonna check the formal charge in here. So this Cl gonna have a positive charge, while this Al gonna have negative charge. can we immediately form positive and negative charge and they are separately? Yes. How do we know this? By looking at your alkyl group. If you have a stable carboxyl ion to be formed like secondary and tertiary, you can already break the bond between the C and Cl. If let's say you has primary carboxyl ion and they got no possibility to rearrange, then you need to bring all these complex ion to the second step. So for these reactions, we are going to form secondary carboxyl ion, which is a stable carboxyl ion. Then we can immediately break the bond between them. So by giving all the electrons on this bond to the Cl, we're gonna get an intermediate species of CH3, CH, CH3 positive, and also AlCl4 negative. So we'll take these alkyl group to the second steps. For the second steps, we are going to involve the reactions with benzene. So we have our benzene. Benzene will react with the carboxyl ion we have formed earlier. This bond will break to take this carboxyl ion in, since we are going to form quite a bulky group attached to this benzene. Then we're going to do it here. So we have our Adrenium ions with HCHCH3 here. And then we're going to have one of the carbon become the carboxyl ion. Moving this double bond to this carbon, showing that we are going to form a resonance structure. So we have another Adrenium ion. Don't forget to write these substituents. This time our double bond is at here and here, means the positive charge is going to be here. And as for the last resonance structure, we're going to have it double bond to be transferred to another locations. So we need to show all the resonance structures that we have formed. So we have H, CH3, CH3. So don't forget to write the square bracket indicating that they are resonance. As for this final step, we are going to retain the double bond inside the benzene. So we are going to take one of the resonance structure we have formed in second step. So we're going to take this structure. We are going to further react this with the Cl, AlCl3 like this. Don't forget the negative charge. So all the electron on this bond will be transferred to the Cl, making them a more electronegative atom with negative charge. And then they will take this H and retain the double bond to the benzene. Then we're going to get a final product of isopropyl benzene with HCl as the side product. That's all for week 10 our tutorial. Thank you.